Everything you think you know about Archimedes is a lie. He wasn't just a bathtub enthusiast yelling Eureka. He was a war machine, a mathematical ninja, and the last line of defense against the Roman Empire. Imagine Syracuse, 212 BC. The air crackles with fear, thick with the stench of impending doom. Roman warships, a seemingly endless line of them, choke the harbour. General Marcellus, a veteran of countless campaigns, confidently anticipates a swift victory. He's underestimated one thing: the sheer, terrifying ingenuity of Archimedes. Syracuse, a jewel of the Greek world, teetered on the brink, a vibrant hub of trade and philosophy, now trembling before the iron fist of Rome. Its citizens, accustomed to lively marketplaces and intellectual debates, braced themselves for the inevitable clash. King Hero Set, a patron of the arts and sciences, found his kingdom on the verge of annihilation. He placed his faith and the city's survival squarely on the shoulders of its most eccentric resident, Archimedes, a name synonymous with genius, but also with a certain unconventionality. He was more at home sketching geometric figures in the sand than advising royalty. He preferred the company of theorems to courtiers. Yet this very detachment from the everyday allowed him to see the world with unparalleled clarity. He saw levers where others saw immovable objects. He saw angles where others saw only walls. He saw destruction, and he knew how to deliver it back tenfold. Archimedes wasn't just a theorist. He was a practical problem solver. While other philosophers pondered the nature of reality, Archimedes was busy inventing ways to hurl rocks the size of houses. He was a master of mechanics, a pioneer in hydrostatics, and a walking, talking arsenal of innovative weaponry. He understood the principles of the universe, and he knew how to weaponize them. Hero Turn, a shrewd ruler, recognized the value of Archimedes' unique talents. He tasked him with developing defenses, with finding solutions to problems that seemed insurmountable. He challenged Archimedes to prove his claims, to turn his theoretical knowledge into tangible results. This royal patronage provided Archimedes with the resources and freedom to explore the limits of his intellect. One story, perhaps embellished over time, perfectly illustrates this dynamic. The king, suspicious of a goldsmith's integrity, asked Archimedes to determine if a crown was made of pure gold or if silver had been surreptitiously added. The solution, legend has it, came to him in a flash of inspiration while bathing, prompting his famous cry of Eureka. But the anecdote, regardless of its veracity, speaks to Archimedes' relentless pursuit of knowledge and his ability to find elegant solutions to complex problems. He was, in essence, a Renaissance man born centuries too early. His writings spanned mathematics, physics, engineering, and astronomy. He calculated the value of pi with unprecedented accuracy. He developed methods for determining the area and volume of irregular shapes. He laid the groundwork for integral calculus, centuries before Newton and Leibniz. Archimedes saw the interconnectedness of all things, the underlying mathematical order that governed the universe. His brilliance lay in his ability to translate abstract concepts into practical applications. He wasn't content with simply understanding the principles of levers. He wanted to use them to move the world. He wasn't satisfied with calculating the density of objects, that knowledge to detect fraud. He wasn't just a scholar, he was an innovator, a creator, a force of nature. Give me a place to stand, and I shall move the earth. This boast, attributed to Archimedes, wasn't mere arrogance. It was a testament to his understanding of leverage. He grasped the immense power that could be unleashed with the proper application of mechanical advantage. He envisioned machines capable of feats that seemed impossible, and he set about building them. The lever, in Archimedes' hands, became more than just a simple tool. It became a symbol of human potential. It represented the ability to overcome seemingly insurmountable obstacles through ingenuity and knowledge. It was a metaphor for the power of ideas to reshape the world. He knew that even the smallest force properly applied could achieve extraordinary results. Archimedes' world, Syracuse, was a melting pot of cultures and ideas. Nestled on the coast of Sicily, it was a vital trading hub, connecting the eastern and western Mediterranean. Its bustling marketplaces were filled with merchants from Egypt, sailors from Tyre, and artisans from Carthage. The city throbbed with life, a vibrant tapestry of sights, sounds, and smells. This cosmopolitan atmosphere fostered a spirit of innovation and intellectual exchange. New ideas were constantly circulating, challenging old assumptions and sparking new discoveries. Syracuse was a place where philosophers could debate, where engineers could experiment with new technologies, and where artists could create masterpieces. It was the perfect environment for a mind like Archimedes to flourish. The streets of Syracuse were a labyrinth of narrow alleys and grand boulevards. Ornate villas stood alongside humble workshops. The air was filled with the sounds of hammering, sawing, and the chatter of countless voices. The harbour teemed with ships, unloading goods from distant lands. The scent of spices, perfumes, and freshly baked bread mingled in the air. But beneath the surface of this vibrant city, a storm was brewing. Rome, the rising power in the Mediterranean, cast its covetous gaze upon Syracuse. The Romans saw the city's wealth, its strategic location, and its potential as a valuable addition to their expanding empire, and they were determined to take it, by force if necessary. The seeds of conflict had been sown, and the stage was set for a showdown that would test the limits of Archimedes' genius and determine the fate of Syracuse. The Roman fleet approached, a dark cloud on the horizon. Compagna praehistoria. Syracuse, a vibrant Greek colony of Sicily, was city. It was a crucible of innovation. Ideas flowed freely. Theories were debated fiercely. Sensori d'Italia. The salty tang of the Ionian Sea hung heavy in the air. The cries of gulls echoed across the bustling marketplace. The sun beat down on the whitewashed buildings, creating a dazzling display of light and shadow. Personalizirvani orbit. Imagine walking those sun-drenched streets, the scent of olive oil and wood smoke filling your nostrils, the sounds of 100 different languages swirling around you. This was Archimedes' world. Archimedes wasn't just a mathematician, he was. He thrived in this environment, soaking up knowledge and relentlessly pursuing answers to the universe's most perplexing questions. He accepting the status quo. He questioned everything. He challenged everyone. He sought to understand the fundamental principles that governed the world around him. His mind was a whirlwind of ideas. New concepts constantly swirled, sparking new discoveries. Syracuse's nature of reality, engineers' technologies, artists could create masterpieces, it for a mind like Archimedes to flourish. The streets of Syracuse boulevards, ornate workshops, the of countless voices, the lands, but storm was brewing. Rome, the Mediterranean, upon Syracuse, the Romans' expanding empire, and if necessary, the Archimedes' fate of Syracuse, the Roman. Archimedes, oblivious to the impending doom for the moment, delved deeper into his studies, fueled by an insatiable curiosity. He sought to unravel the mysteries of the universe, one equation, one experiment at a time. He was particularly fascinated by geometry, the study of shapes, sizes, and the relationships between them. He saw geometry not just as an abstract mathematical concept, but as a key to understanding the very fabric of reality. He spent hours poring over diagrams, sketching figures in the sand, and wrestling with complex problems. He was driven by a desire to find elegant solutions, to discover the underlying order and harmony. He believed that mathematics held the answers to everything, from the motion of the planets to the strength of a lever. His dedication to his craft was legendary. He would often forget to eat or sleep, so absorbed was he in his work. He would pace back and forth in his workshop, muttering to himself, his brow furrowed in concentration. His of calculations, theorems, and hypotheses. Archimedes was not alone in his pursuit of knowledge. The ancient world boasted several centres of learning. Alexandria stood out as a beacon of intellectual activity. Alexandria, a city founded by Alexander the Great, had become cultures and ideas. Its Greek philosophy, Egyptian mysticism, and Persian science converged. The The city attracted scholars from all corners of the known world, eager to share their knowledge and learn from others. Alexandria was renowned for its great library, considered the largest repository of knowledge in the ancient world. Within its vast collections were countless papyrus scrolls containing copies of original manuscripts, covering subjects from philosophy and mathematics to medicine and astronomy. The knowledge of diverse civilizations was collected, systematized, and expanded. When Archimedes arrived, he gained access to works that shaped his worldview and laid the foundation for his future discoveries. The library was only part of Alexandria's scientific infrastructure. The city housed the museum, a research institute and educational institution where scholars studied nature, conducted experiments, and exchanged ideas. The museum's walls echoed with debates and discussions that fostered new discoveries. It brought together the foremost minds of the time, giving Archimedes the opportunity to learn from the best. One of the key moments in his education was encountering the works of Euclid, whose Elements had already become a standard textbook on geometry. Archimedes deeply studied this work, which systematized knowledge of lines, planes, figures, and their properties. Euclid's Elements provided him with a rigorous framework for logical reasoning and mathematical proof. It taught him how to build arguments from first principles, to define terms precisely, and to derive conclusions from established axioms. Euclid's work instilled in Archimedes a deep appreciation of deduction and the importance of rigorous proof. He saw how mathematics could be used to solve real-world problems. This would influence his later work in engineering and mechanics. The time in Alexandria was formative. He learned about the principles of levers, pulleys, and screws, which would later enable him to design ingenious machines for lifting heavy objects. He studied the properties of fluids, which would lead him to discover the principle of buoyancy, famously revealed when he leapt from his bath shouting, "Eureka!" He became fascinated by the concept of infinity, which would inspire him to develop new methods for calculating areas and volumes. Archimedes absorbed all this knowledge and synthesized it into his own unique approach to problem-solving. He combined mathematical rigor with practical experimentation, bridging the gap between theory and application. He was an engineer, an inventor, and a visionary. He returned to Syracuse a changed man, his mind brimming with new ideas and his hands itching to put them into practice. He carried with him the accumulated wisdom of Alexandria, the legacy of Euclid, and the burning desire to push the boundaries of human knowledge. He was ready to transform the world with his genius, but the world had other plans for him. The Roman fleet loomed ever closer, its shadow spreading across the waters. The time for abstract thought was over. The time for action had come. Archimedes would need to put his knowledge to the test, to defend his city and his people from the impending invasion. But that was only the beginning. Archimedes' time in Alexandria proved transformative. He immersed himself in Euclid's Elements, a foundational text on geometry. This wasn't passive learning. He saw Euclid's work as a challenge. He was inspired to expand and develop those ideas. He also encountered the work of Ctesibios. Ctesibios was an inventor who pioneered hydraulics. His inventions included water clocks and pumps. They potentially sparked Archimedes' interest in hydrostatics. This interest would later lead to his famous principle. Alexandria buzzed with astronomical speculation too. This likely piqued Archimedes' curiosity about celestial bodies. He developed access to ambitious thinkers in Alexandria. These weren't just theorists. They tackled practical problems. They focused on city defense, agricultural improvements, and technological innovation. Archimedes absorbed this pragmatic approach. It became a hallmark of his scientific work. Returning from Alexandria, Archimedes was a changed man. He possessed deep knowledge of mathematics, physics, and engineering. He was ready to undertake independent research. Alexandria had shaped his talent. It helped give his thoughts concrete form. Soon after his return, Archimedes dove into mathematical and geometrical investigations. One of his most celebrated discoveries was the Archimedes spiral. It marked one of the first complex figures to be mathematically described. Imagine drawing a line from a central point. The line gradually coils outwards. Each turn maintains an equal distance from the previous one. If you simultaneously rotated a pen and moved it away from the centre, you'd create this spiral. The Archimedes spiral wasn't just a geometric curiosity, it was a practical tool for solving complex problems. Archimedes used it to study and calculate areas enclosed by its coils. This was a significant challenge at the time. Modern calculation methods like integrals didn't exist. Archimedes formulated his own methods to find these areas, his work later mathematical research. The Archimedes spiral had significant practical applications. Its properties were used. For example, spiral pumps designed to lift water were inspired by this shape. These pumps were used even in antiquity. Their principle of operation was influenced by Archimedes' ideas. The spiral is also used in mechanisms where uniform motion is important. Think of gear trains or screw structures. Even today, the principles behind this curve find applications in various technical fields. Archimedes made crucial contributions to mathematics. He developed volumes of complex figures. These anticipated the development of integral calculus. He employed the method of exhaustion to solve such problems. This involved dividing a figure into numerous small parts with known parameters. Then, he summed their areas or volumes. To calculate the area of a circle, Archimedes inscribed and circumscribed regular polygons. By increasing the number of sides of the polygons, he achieved increasingly accurate approximations. Ultimately, he proved that the area of a circle equals the product of its radius and half its circumference. Archimedes also worked on calculating the volumes of three-dimensional figures. He demonstrated that the volume of a sphere is 2/3 the volume of the cylinder that encloses it. This is true if the cylinder's height equals its diameter. He achieved this by slicing the figures into thin sections and comparing their volumes. Archimedes considered this discovery one of the most important of his life. He requested that a sphere and cylinder be depicted on his tombstone. Furthermore, Archimedes calculated the volumes of cones. He proved a cone is 1/3 the volume of a cylinder with the same height and base. He also studied the area and volumes of other complex figures. These include parabolic segments. Despite the absence of modern theories of limits or integrals, Archimedes' approach effectively used the same principles. His work, the future development of mathematics. He inspired later scientists such as Newton and Leibniz. One of the most famous stories involving Archimedes concerns King Hero's crown. Hero II, the ruler of Syracuse and Archimedes' patron, commissioned a goldsmith to create a golden crown. It was to be in the form of a laurel wreath. The goldsmith received a specific amount of gold for this task, but when the work was completed, the king suspected the craftsman might have mixed a cheaper metal such as silver with the gold. However, he didn't want to damage the crown to verify its purity. Therefore, Hero turned to Archimedes. The task was to determine if the pure gold without destroying it. Archimedes pondered the problem for a long time. One day, while taking a bath, he noticed the water level rising as he submerged himself. He realized displaced water equals immersed object. This principle could be applied to the crown. By measuring the crown's volume using displaced water and comparing its mass to that of an equal volume of pure gold, one could contain impurities. Understanding the solution, Archimedes leaped from the bath. He famously shouted, "Eureka," meaning "I have found it" in Greek. He ran through the streets of the city, forgetting even to dress. While this part of the story is likely exaggerated, it highlights the joy of discovery and the magnitude of the discovery itself. Archimedes applied his newly discovered principle to test the crown. He first weighed it in air. Then he immersed it in water and weighed it again. Measuring the difference allowed him to calculate the crown's density. He compared it to the density of pure gold. The results proved that its density was lower than that of pure gold. This story demonstrates the birth of the law of hydrostatics. It is now known as Archimedes' principle. The Roman fleet approached Syracuse. The city braced for war. Archimedes, the scholar, now became Syracuse's. His inventions would be tested against the might of Rome. The fate of his city hung in the balance. He had to be ready to fight. What happened next changed everything. Archimedes' principle explained why objects float or sink. It stated that a body immersed in fluid experiences a buoyant force. This force equals the weight of the displaced fluid. Imagine lowering a ball into water. The water level rises. The displaced water exerts upward pressure on the ball. This upward force is buoyancy. The object's weight and volume determine what happens next. A heavier object than displaced water sinks like a stone. A lighter object floats, like wood. It displaces enough water to equal its weight. Think about lying in a bathtub. Your body displaces water, raising the water level. You feel lighter. The water creates a buoyant force. It partially offsets your weight. Ships float due to their shape. This shape equals their mass. Hot air balloons rise similarly. They displace air. The buoyant force lifts the balloon. Archimedes' law is crucial for understanding fluid interactions. It revolutionized engineering and shipbuilding. After developing hydrostatics, Archimedes focused on mechanics. He studied levers and pulleys. These simple mechanisms eased heavy lifting. Archimedes discovered levers amplify force. Correctly positioning the fulcrum could lift heavier loads. This led to his famous quote, "Give me a lever long enough, and a fulcrum on which to place it, and I shall move the world." This principle became a cornerstone of mechanics. His research made practical application possible. Archimedes designed pulley systems. These compound pulleys used fixed and movable blocks. Ropes passed through them. It drastically reduced the force needed to lift heavy objects. More blocks meant less effort. This mechanism became essential for construction and transport. Archimedes applied his knowledge practically. Levers and pulleys built structures and moved stones. They improved siege engines. Archimedes' work on levers and pulleys explained fundamental mechanics. It showed how science solves practical problems. His discoveries underpin many technologies today. These range from simple tools to complex machinery. Archimedes gained fame as an inventor. He created effective machines to defend Syracuse. During the Roman siege, 214 to 212 BC, his inventions were crucial. Archimedes developed catapults and ballistae. He improved these for throwing projectiles. Stones, arrows, and other ammunition flew far. He calculated angles and sizes. This increased range and accuracy. These catapults targeted Roman ships and siege works. They struck before they reached the city walls. Another invention was the Claw of Archimedes. This crane-like device lifted Roman ships. It grabbed them as they approached Syracuse. Ships rose from the sea, then crashed back down. This caused serious damage or capsizing. Romans watching were stunned by its destructive power. The most legendary story involves burning mirrors. Archimedes supposedly designed a system. Metallic mirrors reflected sunlight onto Roman ships. Focused light ignited wooden parts. This turned ships into blazing targets. The reality of this device is debated. However, the idea demonstrates Archimedes' engineering genius. Archimedes also improved city defences. He designed mechanisms to hinder siege towers. These devices destroyed enemy structures. They worked using levers and pulleys. This made them simple but effective. Syracuse's defence based on Archimedes' inventions lasted over 2 years. His machines slowed the Romans. They instilled fear. Enemy soldiers thought the devices magical. They could not understand them. Syracuse eventually fell. Archimedes' contribution to its defence became legend. Following defence inventions, Archimedes focused on practical devices. He created the Archimedes screw for lifting water. This device was efficient. Its principles are still used today. The Archimedes screw features a spiral within an inclined tube. One end goes into the water,